Hi, everyone. Welcome to our webinar, Improving Building Performance with Digital Twins. Today, we're going to explore what is driving digital transformation in buildings and why businesses, building owners, and facilities managers are investing in digital twins technology. My name is Dale Kaler. I'm VP of Business Development at eMagic, and I have many years leading digital transformation in industries such as construction, manufacturing, and supply chain. Joining me today is Denis Fouché. He's a Senior Specialist Partner Development Manager with the IoT's Americas team at Microsoft. Denis has been with Microsoft for more than 20 years, and he works closely with partners like us to deliver value and impact to our customers. Before we get into our topic, we'd like to provide a bit of background about our two companies. eMagic began in 1998 as a systems integrator. Our founders, Tony Harris and Eugene Wu, were pioneers in SCADA, expert systems, operations technologies, and systems integration. With the advancements in cloud, IoT, and AI technologies in recent years, Tony and Eugene decided to leverage their expertise to build a new systems integration solution built on Azure native services that could be more easily implemented across various industry sectors like buildings, infrastructure, healthcare, and manufacturing. Today, eMagic is a global digital twin solutions provider with its head offices in Toronto and offices in the US, Guyana, India, and soon the UK. Denis, thank you for joining our webinar today. I think we all know who Microsoft is, but could you give us a little background about what Microsoft is doing today with respect to smart buildings?
Absolutely. Thanks, eMagic, for having me and for being our partner, first of all. 5 years ago, Microsoft committed $5 billion to do two things. One, create an edge-to-cloud IoT platform that can securely connect millions of devices. And second, develop the partner ecosystem that would build end-to-end solutions that customers need to rapidly transform their businesses. For us at Microsoft, the Internet of Things is a means to an end, a toolbox that enables digital transformation. In the context of smart places and real estate, digital transformation enables a variety of scenarios that change customers' experience and satisfies people-centric needs like help me find my way, or facility-centric needs such as help the building operator optimize air conditioning and reduce the energy bill. On the platform side, our Azure product group developed a set of IoT-specific tools and services and recommended architectures that customers and partners alike can leverage to develop the end-to-end solution that meet their business needs. At the core of our architecture is Azure Digital Twins, a standards-based and highly scalable service that enables the creation of rich digital models of anything physical, from simple assets or products to complete environments like buildings, campuses, or an entire city. But the partner ecosystem is really what brings our IoT platform to life. eMagic was one of the few partners to have early access to the Azure Digital Twins technology and to rapidly come to market with a transformative solution that will make your buildings, your facilities, and campuses smarter, easier to operate, and more energy efficient. With that, Dale, you have the floor.
Great, thanks, Denis. So let's get into our topic for today. When it comes to a building or facility's operating performance, owners and their facilities managers have historically relied on on-site expertise or vendor-specific software to address problems or initiatives to improve operational performance. However, the world is demanding so much more from its building environments, and a number of issues and key driving forces are pushing businesses, asset owners, and facilities managers to think smarter about how a building or facility is operating. To begin with, the COVID pandemic has completely shifted the way we think about buildings, how we use them, how safe they are, and how they might be used better. One interesting discovery during the pandemic has been that while people worked from home, buildings were less than 50% occupied in 2020, and yet their energy consumption only dropped between 10 and 20%. Addressing climate change requires that all buildings will need to lower their carbon emissions and greenhouse gases. Buildings are said to generate nearly 40% of annual global greenhouse gas emissions. And as a growing factor in capital markets, environmental sustainability and governance is now considered an important priority for owners and investors. And on top of that, energy markets are changing. Distributed energy is creating opportunities for buildings to be prosumers, both producers and consumers of energy. Customer expectations is another macro trend affecting building operations. The users of a building can no longer just be considered tenants or occupants. They're consumers. Being able to understand and respond to their behaviors, their requirements, and their expectations is going to be key to long-term profitability. Another factor and driving force is that the PropTech market has really exploded in the past few years. And now there are many, many devices, tools, applications, and software systems coming onto the market. Many of these address very specific use cases, and as standards emerge, some technologies will prevail while others will fall away. And then finally, with all that technology coming into the building, there are cybersecurity threats and responsibilities that building owners must take on to ensure the safety and security of their operations. With so much driving the need for change, what is preventing building owners and facilities managers from moving ahead with digital transformation and innovation in their building operations? I think many of these face common but very difficult challenges. The first is not having a coherent digital strategy or data strategy. It's easy enough to find specific use cases to address, but in isolation, they won't necessarily have the big business impact that they might be striving for. Another thing is data silos. With so many devices, both new and old, creating data, and all types of data sitting in different silos, it's daunting to think about how to aggregate it all. And in many cases, building equipment generates data that isn't very clean, accessible, or usable. So it really requires domain experts to untangle everything into a normalized state that can be used. Another roadblock is that the pressure to drive down costs and increase efficiencies also has to be balanced with the comfort and service levels that are needed for occupants and tenants in the building. And similarly, unplanned disruptions from equipment failures or unplanned maintenance can really mean significant unexpected costs and poor customer service. And for many businesses, their early sustainability efforts might have yielded good success because they were able to address the low-hanging fruit, but then it plateaued. Continuous improvements in operational efficiency requires much more information and a better understanding of what's going on. And finally, staying on top of cybersecurity threats and vulnerabilities as operational tech, OT, and IT converge together, it can really hamper digital adoption, especially for those that might lag behind in their digital adoption or be wary of new innovation. So let's hear from Denny about what Microsoft is seeing in the marketplace.
Thanks, Dale, for your description of the drivers for digital transformation in the smart places sector. Let me now share a few quantitative insights from surveys by the likes of McKinsey, Beam Today, and Deloitte. Those independent surveys confirm that demand for smart building solutions, thanks or despite of the pandemic, is increasing, as the first three indicators on the left show. To highlight only one, the fact that 50% of the building devices are expected to be connected by 2025 sends a clear message to all of you, all of us. This is happening. Don't be left behind. The fourth indicators on the right shows that the construction sector strongly believe that this is a long-term trend. And the last two confirm that smart building technologies will bring significant energy cost savings and all-up operational savings. But although it's the first on this slide, cost saving is only one of the benefits for adopting new technologies such as IoT. IoT can also bring workplace innovation, improve productivity, verify that health mandates are met, but also attract and retain talent. IoT helps companies track how they're doing against their sustainability goals, such as the reduction of energy consumption and the use of renewable energy sources. Like in many other sectors, IoT enables the concept of predictive maintenance of building devices and equipment, which in turn contributes to more efficiency and reduced costs. And last, the use of IoT and new technologies can boost your brand and be used by your marketing to attract customers, employees, partners, and investors. And let me use Microsoft's example to illustrate what I just said. The campus refresh project that will complete in 2023 replaces 12 older buildings of our original campus in Redmond, Washington, with approximately 3 million square feet of office space within 17 new buildings. This project brings all 5 benefits to Microsoft. Operating the new campus is expected to cost less, although it will accommodate more employees. It will showcase the latest in workplace innovation. It will include its own geothermal energy plant and be certified for zero emissions and zero waste. We will make sure that all building equipment is smart and maintenance can be predicted. And last, it will be used to attract new employees and boost our brand. And now, Dale, back to you. Tell us how your Smart Places solution helps companies on their digital transformation journey.
Great, thanks, Denis. So TwinWorX Digital Twin Solutions helps businesses to eliminate some of the roadblocks we talked about and also enable them to reap the benefits of their investments in IoT and digital transformation. Built on Azure native services, TwinWorX is a scalable, secure, and highly available platform that works at the edge and in the cloud. It integrates and aggregates, normalizes telemetry data from IoT devices, sensors, and other data points into a single database platform so that real-time and historical information can be surfaced up into a single pane of glass view and analyzed to provide monitoring, alarming, reporting, and fault detection and diagnosis. And together, these integrated connected devices provide capabilities for workflow, process optimization, along with trending, predictive analytics, using machine learning and AI. So how does TwinWorX do this? TwinWorX is built on Azure native services, and it models the physical world of people, places, and things into virtual replicas called digital twins. This enables businesses to connect, integrate, and utilize data from those entities at scale. To do this, we create models of all the entities that we want to connect, and we create twins of these models. We use a common language called Digital Twins Definition Language, or DTDL, and we apply industry standard languages like Real Estate Core, which enables digital twins to relate to other digital twins. So for example, we would create a model of an air handling unit and then create a twin for each air handling unit that's been physically installed in the building. We can onboard physical devices, sensors, and systems into TwinWorX using our enterprise service bus, which has a library of pre-built connectors to hundreds of systems, protocols, and services. And also with bidirectional communication, we can connect all telemetry data and also issue commands for turning equipment on or off, adjusting settings, and optimizing equipment performance. TwinWorX aggregates and normalizes data for all the connected systems into a single database in the Azure cloud, which services are historian, alarming, and reporting. We also surface up data and information into a single pane of glass visualization for computer, mobile, and mixed reality devices. The database of quality data serves as a foundation for our analytics, such as fault detection and diagnostics, and time series insights. Ultimately, what we end up with is a real-time connected system of systems that continuously collects data about people, spaces, and things within the building environment. And the value of this data increases over time because with historical data, we can drive predictions with machine learning and AI, and we can conduct simulations and scenario planning virtually with the digital twin instead of a physical piece of equipment. So, for example, we could start to model how our air handling unit might perform with changes in occupancy patterns and different tenant uses. Or even on a grander scale, we could predict the useful life of a building and its financial performance based on different usage scenarios and revenue models. When we implement TwinWorX in a smart building solution, we provide a full solution with capabilities that support centralized operation of all core and shell systems with monitoring and also command and control of the building systems and equipment. We also provide analytics that drive visibility and intelligence to facilitate data-driven decision-making and driving increased operational efficiency. We are able to support integrated workflows that streamline processes across multiple systems. For example, we might integrate access control with elevator systems and amenities booking systems in the building. And finally, we want to extend out the platform into tenant engagement and experience apps that integrate the building systems with the people who use it. TwinWorX lays a foundation for modeling people, spaces, and things across an array of systems that could be integrated into a building during its entire lifetime. Similarly, this foundation serves integration and interoperability in other industries as well, such as infrastructure, healthcare, manufacturing, and so on. The reason digital twins are so foundational to strategic digital transformation in buildings is that they create a flexible, adaptable way of connecting the vast number of building systems, devices, and sensors together. When we build a digital twin, we're pulling together some very strategic building blocks. First of all, we have a model with its fully defined attributes, capabilities, connections, and relationships. For example, we understand not just the components of the air handling unit, but the data that it generates, how it relates to the spaces that it services, and other equipment systems in the building. And we use an open source common language, DTDL, that all systems providers can also use. So using a common vocabulary means that we're enabling interoperability because they speak the same language. And for owners, that means lower systems integration costs, making systems integration easier, and most importantly, making systems integration resilient to ongoing changes in the future. Another key building block is that we're using a graph database for these models and their relationships. In a hierarchical, traditional database structure, these complex relationships can be difficult to configure without making the whole system fragile. So model architecture makes the relationships flexible and adaptable and usable for integration, extensibility, and of course, queries. So for example, you might query the system about which rooms were above 23 degrees Celsius at 2 p.m. on Tuesday, which air handling units were servicing those rooms, how much energy those air handling units were consuming, and from what sources they were drawing from. We're also building virtual replicas of real-world objects that are then animated by telemetry data. And ultimately, what brings it all together and what makes digital twins strategic is that they bring a new understanding as to how smart assets will behave in the context of a smart environment. And these connected systems will grow across the campus or across the city, and we can see how much smarter the overall ecosystem becomes when smart buildings are interoperable with the smart city, smart energy grid, transportation, weather systems, and so on. Companies that have adopted TwinWorX are able to monitor, visualize, control, and optimize their assets, and they can realize very tangible outcomes. Things like energy savings, a reduction in maintenance costs, a reduction in operating costs because of a single pane of glass visualization, a reduction in IT and OT capital spend, and of course, the impact of fewer unplanned disruptions and less downtime. So let's take a quick look at a demo of our smart building solution. With TwinWorX, owners and facilities managers can view a whole portfolio of properties on a single pane of glass screen. We can navigate through a grid view of different buildings or use a map to intuitively see buildings within a certain geographic area or campus. Users can quickly review summary operational performance shown as red, yellow, green indicators for each property. And on the bottom toolbar, we can quickly see and access different operating perspectives of a selected property. As we hone in on a specific facility, we can monitor its current operating status with real-time information from the building's mechanical systems displayed alongside information about urgent actions or open work orders. These tiles also summarize historical trends such as current energy costs, energy intensity, and carbon emissions. The tile-based display is configurable to the user so that they can see the metrics and data that are most relevant to their role, enabling them to be far more productive and responsive to issues as they may arise. TwinWorX Explore is a tool that offers an immersive 3D navigation experience and an intuitive way to navigate a property and its spaces. In TwinWorX, we mesh the digital twins of assets, devices, and sensors with geospatial information of a 3D BIM model, using gaming technology to provide a highly intuitive fly-through navigation experience. Focusing more closely at specific areas, we can do a virtual walkthrough of a floor to see its spaces in first-person perspective. Or flip up to a 2D floor plan view. When we overlay real-time HVAC, lighting, occupancy, or other types of data, we can quickly understand what spaces are currently in use inside the facility. And as we collect data from connected systems, we begin to build a highly valuable database that can be used to analyze space utilization and comfort and service levels tied to energy and carbon emissions, providing asset owners with powerful information that they can use to make data-driven operational and financial decisions about the space. TwinWorX provides centralized viewing for searching and monitoring a building's assets using our insightful analytics and FDD, or fault detection and diagnosis algorithms. We can search for equipment assets by type or space and efficiently review equipment like air handling units, boilers, and chillers. The digital twins of building assets like this air handling unit define all the properties and the elements and its capabilities. The highly visual graphics dynamically highlight current operating conditions coming in from real-time telemetry data from the device itself. Supporting information about operating trends, activities, and work orders can be easily accessed to provide a cohesive picture of the equipment's capabilities. This dynamic view is accessible on desktop, mobile, and mixed reality devices, such as the HoloLens, where we can bring digital twin operating visuals into a physical workspace, access drawings, reference materials, and connect to remote support. TwinWorX Insights analyzes streaming data for trends, event patterns, and anomalies. Our FDD analytics detects and diagnoses equipment faults and advises on how to improve performance. Human expertise is reflected in our library of more than 400 customizable rules that reflect the context and dynamic environment in which building faults may arise. Operators can prioritize their fault response by anticipated fault costs provided on the single pane of glass. To get an even deeper understanding of how this equipment is performing, our user can look at historical analytics based on our time series insights, a powerful data engine that analyzes streaming data to identify trends, anomalies, and patterns. So, in just a few minutes, we've been able to see how the TwinWorX Digital Twins platform provides a single pane of glass view of a building and its operations. Our customers can monitor all of their building assets and environments. They can visualize in real time the building, its people, its spaces and things, and they can centrally control all the building systems and equipment. And with the support of trends, fault detection, and insightful analytics, they can optimize the building's performance. One of our customers, Colorado University at Boulder, recently implemented TwinWorX to solve some of their building challenges. The University of Colorado at Boulder was looking for ways that they could manage near-time utility data. They wanted to increase the security, resiliency, and availability of facility services. And of course, they wanted to improve the end user experience of students and faculty on their campus. And they obviously wanted to reduce their operating costs. So they reached out to eMagic, and we implemented our TwinWorX solution, where we connected and collected telemetry data from energy meters, and we aggregated all that data into a single database platform where we surfaced up insights and reporting into a single pane of glass view in TwinWorX. The value to CU was intangible. With TwinWorX, they were able to reduce IT expenses in hardware, software, and licensing, and they also saved time and were able to improve services as well using real-time reporting and insights about energy usage. And finally, they were implementing a reliable, scalable, and interoperable digital twins foundation that they could scale out to more buildings and the entire campus as a whole. With that, I'd like to bring our webinar to a close. Thank you all for joining us today. I hope you're able to learn something about how digital twins can drive greater operating performance and support a digital transformation strategy with your building operations. Thank you, Denis, for assisting me today and providing your insights. If you would like to learn more about digital twins and our TwinWorX solution platform, please visit us at emagic.ca, visit our Azure Marketplace offering, or contact us on our social media channels. Thank you very much.